from my Office of Science, pretty much, which is pretty much a room between Mrs. Dennis's and Mrs. Campbell's room. But I wanted to create a video of seasons and kind of to mock or model the demonstration that we're going to do in class on a bigger room, bigger scale. I'm going to use this light bulb here, which I'm going to unblock the view for you a little bit. Okay, I'm going to use this light bulb here. It's pretty bright to represent our sun, and then I've got my Earth here that's going to represent, well, obviously Earth. So what I'm going to do is I'm going to show you the orbit of the Earth as it travels around the sun, and that way you can kind of see the way the light hits the Earth and the spots it hits the Earth. And then what we'll do is we're going to fill out this chart, which I'll send to you separately, or I'll have separately. And as we fill it out, I will put more stuff in it for you to add. And you can pause this video at any time to add what you need to add as the sheet's showing to you. All right, so we know the orbit of the Earth around the sun to be, make your sight a little better. We know the orbit of the Earth to be elliptical. Okay, so the Earth travels around the sun. So if this is my sun, the Earth makes a elliptical path, and you'll have to bear with me as I come around. My arm's going to get in the way. As it travels around the sun. Now, what's going to happen is I'm going to stop the revolution of the Earth around the sun in 4 different spots. Now, one's going to be tough to see because it's going to be over here. So you're going to have to take my word for it because, well, if anything, it's blocking the sun on you right now, but you can't see what it's lighting up. The other 3 spots, it will light up. Now, if the Earth sat in space like this, if the Earth sat in space like this, straight up and down, we would have equal light on both hemispheres. Equal day, equal night. The sun would strike all the time along the equator, giving us equal day, equal night. However, the Earth does not do that. The Earth is not straight up and down. It is tilted. And it's tilted about 23.5 degrees. Now, this is approximation, not the exact. Okay, but it's tilted about 23.5 degrees. Now, because of that, some areas during the year that's facing the sun is going to get more light. Areas that are not facing the sun or leaning away from the sun are going to get less light. So what happens is when the Earth is making its pathway around the sun, there's times where the northern hemisphere gets more of the sun, and there's times when that's happening, the southern hemisphere is getting less of the sun, and vice versa. But then there's the other 2 seasons, the beginning of spring and the beginning of fall, where the Earth is actually hitting the area, or the sun's hitting the area of Earth, which is the equator, and neither hemisphere is getting more or less light. They're getting equal amounts of light. That's what the equator means, equal light. That's what we're going to get to the equinoxes. Okay? So I'm going to start the rotation because I want to show you, I will take out one of the equinoxes, but I want to show you the summer and I want to show you the winter. Okay? So it all depends on where I start. So let me start here. Okay? Now, because it actually, with the light being blocked, it can kind of give you an idea of what I'm talking about. So what happens here is the light is shining, and I know you can't see it, it's basically shining directly here right now on the equator. So I'm guiding my finger here. So which means the upper hemisphere and the lower hemisphere, neither of those hemispheres are facing towards the sun. The southern hemisphere is facing that part of space, and the northern hemisphere is facing that part of space. Neither hemisphere is facing towards the sun, which is this one. So what happens here is the sun's going to shine directly on the equator, and it's going to give equal light to the northern and the southern hemisphere. And like I said, you have to take my word for it because that's what's being blocked right now by the sun being blocked. Okay, on the other side of this globe that you can't see. So what happens is equal lights coming to both sides, and what that gives us as well in seasons gives us equal day and equal night. 12 hours of daytime and 12 hours of night. So what happens when the Earth is going to orbit around the sun is the sun's light, direct light, is going to shine at different places along, above and below the equator. So the first day of fall, this is what this is going to be. Actually, this will be the first day of spring. Let's do the first day of spring. Let's say this is the first day of spring, March 20th, 23rd. It's the vernal equinox. The sun is shining directly on the equator, giving equal day and equal night. Okay, so I'm going to put this down for a second. Put it up here so that way I at least have it somewhere. And with that, let me fill in the spring part. So, spring, call the day the vernal equinox. sun is shining directly on the equator because neither part of the Earth is facing the sun. Altitude in Boyertown, I'm just going to give you a number. Just take my word for it right now. And how many hours of day and how many hours of night? 12 and 12. Okay. I'm going to show you this to start. Spring is the third one down. This one, oops, this one here. Straight out for you. Spring. And then March 23rd, vernal equinox. Sun shines the equator, and it gives us equal day and equal night. So again, if you need to pause the video, by all means go ahead. Okay, so now continuing on, as we start spring, as it starts to move through the months of March into April and May, and then eventually in June, which is the first day of summer, the Earth is going to orbit. You can kind of see in my orbit here. Okay, notice how the Earth's position or tilt is not changing. And then all of a sudden it gets to a point where it goes in that oval, not a perfect oval, but it'll work for now, where now we're in the June months. So that was April and May, and now this is June. The sun is shining directly up here. Because of that tilt, it's not shining the equator, which is down here. It's shining to a point 23.5 degrees above the equator. Now, that latitude is called the Tropic of Cancer. So in the first day of summer, which is June 20th, 23rd, somewhere in that range, the sun shines directly on the Tropic of Cancer, and that's what's going to give us more daylight because we have a lot more direct light. The sun's going to take a longer path to travel across our sky until it sets. But the southern hemisphere is getting the opposite effect. The southern hemisphere is getting less light, less indirect light is hitting the southern hemisphere. They're in their first days of winter in June 20th, 23rd. The dates stay the same. Okay, so I'm going to come back. And right up June, first day of summer, we call that day the summer solstice. Now the word solstice means biggest change in day to night, which means that it's the longest day and the shortest night. When we get to the winter solstice, it's the longest night and the shortest day. That's the opposite. So in the southern hemisphere, they're going through winter solstice, while the northern hemisphere is going through the summer solstice. So 23.5 degrees north is where the sun's shining, and it's called the Tropic of Cancer. Sun's altitude in Boyertown is the highest it's going to get. Again, just take my word for it. Because if you were here for the planetarium, you would see what I was talking about. And day to night is 15 and 9. 15 hours of daylight, 9 hours of nighttime. So the bottom part of this, okay, the summer solar solstice, okay, Tropic of Cancer is where it's hitting, 73.5 degrees, 15 hours of daylight, 9 hours of night. Okay, let's continue. I only have 15 minutes, so I gotta continue on. Now, as it orbits, comes around here, let's say we're placing it that way, okay? As it orbits, as it comes around here, we're going through June, July, and then August, and then eventually September. I'm going to lift it up a little higher so you can kind of see it. Now, in this month, I know it's tough to see that the light is blocking you here. In this month, the northern hemisphere is facing that part of space. The southern hemisphere is facing that part of space. So neither of them are facing the sun. This is the first day of fall. The sun is shining directly on the equator in an equal day, equal night, and we call it the equinox. And this time it's called the autumnal equinox. That's why we heard the word autumn. Okay, so the autumnal equinox, light shining day and night, and now the sun is moving its direct light more south than where it was before. So to swing back around, fill this in. Fall and autumn, we call it the autumnal equinox. Sun is shining directly on the equator. 0 degrees. Sun's altitude, again, 50 degrees in the sky. That's just how high it gets at noon on that day. And then hours of sunlight, 12 and 12 again. 12 day, 12 night. So I'm just top row we're doing now. Just make sure you can actually see it. Okay, there we go. Alright, 12 hours a day, 12 night. Shines in the equator. It's called the autumnal equinox. And that's the first day of fall or the first day of autumn, however you want to say it. Finally, from September, the sun continues to move in its orbit, October, November, then eventually to December. Now, in this case, In this case, now the sun is shining directly down here. And again, it might be tough to see, so they block a little bit. And the sun is shining directly down here, which is below the equator. How far below the equator? 23.5 degrees below the equator, what we call the Tropic of Capricorn. So the sun is shining directly on the Tropic of Capricorn, so which means the southern hemisphere is getting more of the direct light. The northern hemisphere is facing away from the sun, getting less of the direct light. So you have summer here and you have winter up here. So for us in the northern hemisphere, get this off. Whoa, it went dark. There it is. Okay, sorry. So for us here in Boyertown, it is the shortest day and it's the longest night. So season being winter, December 20th to 23rd, okay, right around Christmas time. Name of the day, we call it the winter solstice. Because again, there's the biggest change in summer to winter. The sun is shining directly at 23.5 degrees south latitude below the equator. So now it is the Tropic of Capricorn. Sun's altitude is going to be the lowest it's ever going to be in our sky, and that's 26.5 degrees north. That means the sun does not shine very high and does not carry very hard, so it's a shorter day. Okay, when it was 73.5, it had a longer path it had to travel to get from sunrise to sunset. Now you have 9 hours of day and 15 hours of night. So that gives a little bit of explanation to our seasons, and because we have less direct light from the sun because of the tilt of the Earth, is why we're getting the extremes of hot in the summer and extreme cold in the winter, but what's going on in the northern hemisphere is going on exactly opposite to what's going on in the southern hemisphere. So here's the rest of the chart. It looks like I did this in time. So here's winter. So if this is a little confusing, I do apologize. I'm doing this off the cuff. I'm really not doing this multiple times. I'm just kind of showing it to you once. But you can review the video and pause if you need to write any of this stuff down. But that's how we fill out this chart. It gives us the indication of the stuff that's going on in our seasons. So I hope this made sense, showing the orbit of the sun or the Earth as it travels around the sun. The fact that we're tilted, it gives different amounts of light to the northern and southern hemisphere of the Earth. And from there, when it's during the equinoxes, it shines equal day, equal night. And again, if the Earth was straight up and down in space, then we'd have winter and spring all the time. We wouldn't have the extremes. Or fall and spring all the time. We wouldn't have the extremes. Since we have the tilt, we have the extremes. Hope this made sense. Have a good one.